Now the first 7.1 says, how many years will it take for an article to depreciate to half its value according to the reducing balance method at 7% per annum? Well, what you need to know the key terms: half its value, reducing balance, and what else? Depreciate. Right? It's depreciating, it's not increasing. So now we use this formula. A is called P1 minus I to the power N. Alright? And we are not given the value of P, neither are we given the value of A. But what are we told? Half. So A is half of P. So A is half of P, or P over 2. Now from there, now we put A on our formula, which is P over 2. Then we put P over 2 is called P1 minus. How about our I? 0.07, 0.07 to the power N. Now we use this formula because it's depreciating. That's why it has got a negative. And also reducing balance. It's a compound formula, right? Now let's work it from here. Now this is like half P. Half P is called P1 minus 0.07 to the power N. Right? Now these P's, they cancel each other, right? If a P is on the other side, the other one on the other side, so they cancel each other. So these P's, they go. Now we remain with half. It's called, now this one 0.93, right? To the power N. Now this is an exponential function. Now to solve for N, we have to apply logarithms. Alright, now we apply logarithm both sides. So log half is called N log 0.93. Alright, now to get N, we divide all the sides by log 0.93, log 0.93, log 0.93. Now this goes like this. So N is what? N is called log half all over log 0.93, right? Okay, let's try it here. So N is called log half over log 0.93. Now you can punch in your calculator. What do you get?
9.555.
That's it. That's it. So we're going to get 9.551. 13. Okay, let's just leave it to two decimal places. Alright, so our N is 9.55. Yes, that's it. Don't leave it, eh? Yes. Alright. So we are done with this one. Clear?
Yeah. Do we not have to? Okay. There when it says 9.55 in the whole thing, aren't you is it wrong if we like take 0, all that, because you already know that it's 9 years, and then multiply it by 12, because then it becomes different. It becomes 7 months instead of 5. So I want to know if.
Or like 9.55 years.
Yes, and then you take 0.55 plus the whole thing that follows, and then you times it times 12. It becomes a different thing. So I want to know if we're supposed to do that.
But for this one, there was no need to do that. Sometimes if the question just say how many years or how long, you don't need to express. Unless if you specifically say express in months, then this one you have to times by 12. But if you just years, then 9.55 years done. It's fine. Alright.
So, isn't it here we calculating the using the reducing balance method?
Yes.
So how can you tell or which formula to use, since we're given 6 different formulas for financial maths.
Well, the other 6 that you're talking about, I'm not so sure about them. But now for this one, remember there's a straight line and then there's reducing balance. Straight line, you are saying the value is depreciated by the same amount, right, throughout. Reducing balance is not the same amount. Like reducing balance, we are reducing from the balance or the amount that we are given with a certain percentage. Like maybe here we're going to reduce by 7% every year on the balance, right? Not on the cost. So whenever you're told that reducing balance, we need to use this formula because it's for discount, so to speak. But if it's a straight line method, you need to use what? This formula. For straight line, you use A is called P1 minus I N. If it was a straight line, you're going to use this. Reducing balance, you're going to use this. But now, how do we know whether we're going to use this formula compared to the other ones that you have said? Remember the other ones, some of them they are used on annuity. This is not an annuity. We are just looking at present value and future value. So we use this present value, this is future value, so to speak. Right? So that's the formula that we use. We don't use for annuity, we don't use for sinking funds. Of course, we are given those formulas, like all the formulas. But we don't use them. Alright. The other, for negative is discount. For plus, which means it's what? Yeah, it's increasing. The other one is discount, the other one is increasing. This one is discount. That's why they say depreciation. Remember, depreciation is going down. Is it clear?
Yes.
So always when reducing balance, use this one. For straight line method, use that one. 7.2. Right. We are told that there was 2 friends. All right. They received an amount of 6,000 to invest for a period of 5 years. So this is the amount of money, 6,000 to invest, right? So this is sort of a present value. For how long? For 5 years. So N is got 5. All right. And then they invest the amount of money as follows. We are given 2 people. There is Rajesh and Tani. Now, we are told now, this is how they, after they've been given money for 5 years, this is how they invested. Now, Rajesh invested 8.5% per annum, simple interest. So this one is simple interest. Let me just say SI. And then 8.5% per annum, 8.5%. Then also, we are told that at the end of each 5 years, you will receive a bonus of exactly 5% of the principal. So bonus 5% of the principal. Now this is Radesh first of all. Now let's go to Chandy's condition. He's going to invest it at 8% per annum, compounded quarterly. Okay? Quarterly compounded. So M is what? 4. With number of times interest is compounded. It's quarterly, so it's 4, right? Mm-hmm. Now, we are told who will have the bigger investment after 5 years. Alright? Who will be having bigger investment after 5 years. So what are we looking for here? We are looking for future value. Alright? So now, let's start with Radesh first. Now, the working is as follows. He's going to invest 6,000, but let's use the formula first. The simple interest formula, right? Simple interest formula. Because the amount of money is going up, it's not decreasing. So we're going to use A is equal to P 1 plus. Alright? So now, what is our A? That's the one that we're going to look for. So A is called. What is P? P now is 6,000. 1 plus. What is our I? 0.085 times n, 5 years. Right? What is the answer there? Sorry?
8,500.
Yes, that's it. 8,550. Now, but remember, this is the amount of money that is going to get after investing 6,000. But remember, he has got a what? A bonus. So now, but what is the bonus? 5% of the? Yes. So bonus also is called 0.05 times 6,000, giving you what? 300. Now, so by the end of the period, she's going to get how much total? 8,850. That's it. So this plus this, giving you that. That is what she's going to get by the end of the 5 years. Alright? Remember, the question is saying, who will have a bigger investment? So now let's go to Tandy. Alright. Remember, Tandy is invested at a compound interest, alright, at 8%. So now we use the compound interest formula again. So Tandy, now we say A is equal to P1 plus I to the power N. So now we're looking for the future value. So A is P, 6,000. 1 plus, what is our I? 0.08 to the power N. Punch in your calculator. What are we going to get? Alright. But there's something there. Have you noticed? Now, our I interest is being compounded how many times?
4 times.
4 times. So which means our I is going to be divided by 4. Alright? And how about our N?
It's mathematical.
That's it. So N is going to be 4 times 5. Alright. So this is going to give you 20. 0.08 over 4.
0.02.
So
6,000.
6,000.
1 plus 0.02.
0.02.
Square root and exponent of 20.
Yes. So what is the total figure?
8,915.
8,900. Yes. 8,915.68. Now, this is very important. Make a distinction like this. But then from there, remember the question says, who will have a bigger investment after 5 years? Justify your answer with the appropriate calculations. So, we have done the calculations. What is the answer now? Tandy is going to receive bigger investment. Alright. Now, justification, the answer proves. This is 8,915 against 8,850. Clear?
Yes.
So this is question 7.2. Now let's look at that one. Nikki opened a savings account for with a single deposit of 1,000 on 1 April 2011. She then makes 18 months deposit of 700 at the end of every month. The first payment is made on 30 April 2011 and the last payment on 30 September 2012. The account ends interest at 15% per annum, compounded monthly. Alright? So now, let's have this. We are going to have the one for single deposit. Alright? And the other one, when you are making regular payments every time for a given interval of time, we call it annuity. So we're going simple deposit plus annuity. But remember, we're looking at, it said determine the amount that should be in your savings account immediately after a last deposit is made. So we are looking at future value, alright? Because she's making payment so that she will use it. It's a future value. So now let's look at we are told that it's 18 months, alright? So our N is 18. Now, as for our I, remember I told that the account earns interest at 15% per annum, but compounded monthly. Please keep note of those. Alright. So now our I is going to be 0.15 all over 12. Alright. That's it. So now let's punch in our formulas. Now for the single deposit, the initial deposit that was made, like that 1,000 rand. So we have to say 1,000. We have to use the simple discount formula, or single discount formula, not annuity. We have to separate between this and this. Now that's where it comes to your question to say which formula do we need to think when we are doing this. Now as for single deposit, we use a is called P1 plus I to the power n. Alright? This is single deposit. Now for annuity, we use the future value. That's it exactly. So we have got X, which represents the annuity. Let me just check on the formula. You can also do the same in the exam. So it's X 1 plus I to the power n minus 1 all over I. Right. So now let's come here. Remember, we're looking for the future value. Now for this single deposit. So we're going to say it's called our P. How much is it? 1,000. 1 plus our I 0.15 over 12. Right. And our N 80. Alright, that's it. So now, and then we also incorporate this, the one for the annuity. X means regular payment, or the amount of money that is being paid every time, which is our 700 that is paid at the end of every month. And then big bracket 1 plus, what is our I? 0 over to the power 18 minus 1 all over 0.15 over 12. Alright, if you punch in your calculator for the first one, you're going to get 1250.58, right? Then just flip it around off to 2 decimal places, right? And then for this one, what are we going to get? 14. All right, are you getting the same answer?
175.40.
Yes, yes, yes. Okay. You can work them separately, stage by stage. But when you punch exactly the calculator, you should get this is the correct answer. Alright. Now, this 1250.58 is for this single deposit of 1,000, right? That was made at the beginning of April. Now, this annuity of 700 rand every month. Now we're going to get 14,032. Then we add the 2 to get the total amount of money or the future value that we're going to have. Question?
I have a question. I need to find out that also below on the run for X, do you have to put 12? Is it necessary to put yes, there
On X?
there on I?
On I?
Yes.
Yes. Yes, you put 12. Well, the formula on every I, when you are told that interest is compounded maybe less than or more than once a year, wherever there's I, you divide by 12. No, divided by M, or number of times interest is, in this instance, 12. So wherever there's I, you divide by 12. Right? And wherever there's N, you multiply by 12. If it's yearly. But in this instance, it's monthly, so it's alright. Because this one, we're going to say 18 over 12 times 12. Those 12 cancel each other. You remain with 18. Alright, so the total there will be 1528.91. Done. So that is the amount that should be in your savings account immediately after the last deposit is made. Is it clear? Now let's do question 8. Alright, if you notice on question 8, it talks of f prime x. It means derivative. Alright, so now it says determine f prime x, or first the derivative of f of x. Now check, it says from first principles. So if you don't use first principles, you're not answering the question. Okay, so in the examination, make sure you don't create your own question. Follow the question that I give you. Now it says that f of x is called minus 4x squared. Alright, now from the first principles, now using the first principles is the one that we say f prime x is called limit as h approaches 0 of now f of x plus h minus f of x all over h, like this. Your limit should not be before the equal sign. No, it's wrong. If you leave the limit, it's wrong again. So write it properly as it is. Alright, don't leave this one, don't put it on this other side. It should be exactly as it is. Now let's look for f of x plus h. Let's just do those steps one by one. Now f of x plus h, we go there. It's minus 4. Wherever there is x, we are putting x plus h. That's what it means. So we are going to say minus 4x plus h squared. Alright, now we're going to have minus 4x plus h, x plus h, minus 4. Now we expand it according to the way x squared plus xh plus xh plus h squared. Now minus 4x squared plus 2xh h squared. Alright, and then putting everything like minus 4 inside, opening the bracket, we're going to get minus 4x squared minus 8xh minus 4h squared. Alright, so now we got f of x plus h. Now let's just input it here, and then f of x is given there, and then we divide everything by h. Right, so let's turn it there. Remember, so first derivative is gonna be, alright, limit as h approaches 0. Now what do we have? Minus 4x squared. Minus 4x squared minus 8xh minus 4h squared
Plus 4x.
now. Okay, that's it. So we have got f of x is there, so minus 4x squared, right? So it's gonna be minus 4x squared, right, over h. Now going with it again, it's gonna be is h 0 minus 4x squared minus 8x h minus 4h squared plus 4x squared all over h. Alright, so now limit is h approaches 0. Now this one goes, alright?
Yes.
And then we're going to remain with minus 8x h minus 4h squared. Now this is all over h, right? Now we're going to have limit is h approaches 0. Now let's factor out h. Minus 8x minus
4h
over h. Now we're going to get limit is h approaches 0 minus 8x minus 4h. This goes, eh? Then we remain with this. Now, but remember, it says as h approaches 0. So, as h approaches 0 here, this will become 0, isn't it? Yes. So we're going to remain with that is what? Using the first principles. Alright? If you just say minus 8x using another method, that one, you don't get it. So use the first principles. Alright? So those are the first principles. Any question?
So let's just say you want to check if your answer is correct.
Yes.
You can use the derivative formula.
Yes.
Okay.
But to answer that question, you need
The first principle.
yes. So if you just use that derivative, you are creating your own, and then you answer it. Yes.
I want to know when the negative 4h went. I didn't see that part, how you did it. Like it's negative 8x minus 4h here.
Yes. We are saying like as h approaches 0, remember that's what it says. So as h approaches 0, what is going to happen to this whole thing?
It becomes positive. I'm not sure.
Okay. Minus 4 times 0. What is the answer?
0.
So it becomes minus 8x plus 0, which is nothing.
Okay.
Alright. Because it's as h approaches 0, that's how you get it. Clear? So we can move on. 8.21. Now it says there, evaluate dy over dx if y is equal to 3 over 2x minus x squared over 2. Now, this is where you use the rules of derivatives. Now, that rule says if y is equal to x to the power n, then dy over dx is equal to nx n minus 1. Alright? So now, we want to apply that. Now, if you look intently on this one, it has got x underneath. But we can bring it to our level, so to speak. Whenever you're dealing with this, bring them to your level or express them to the way that you understand so that you can be able to apply that rule. Alright? So now, we can say 3 over 2 x to the power minus 1. Alright? And then minus x squared over 2. Then from here, remember this is, now from here now we apply, this is still y, and then when you are saying dy over dx, now is where now we'll be saying, remember that rule, so it's minus 1, 3 over 2 x to the power minus 1 minus 1. Right? Minus now 2 x over 2 to the power 2 minus 1. Okay, now this one will becomes negative 3 over 2 x to the power negative 2. Now this one, this goes and this goes, so it becomes minus x to the power 1. Right? Now by the end of the day we have got it's called minus 3 over 2. Now we bring back that x down. Right? When it goes down, it's no longer negative. It's positive. Yes. Minus x. Any question on that? So that's evaluation dy over dx. Simple stuff, isn't it? Okay, now let's get to 2. Now it says there, evaluate first derivative of 1. If f of x, now we are given f of x is equal to 7x plus 1 squared. Now this is very simple. 2 methods of working it out. But now, the first one, which is very simple, you just say f of x, expand this one, right? You can just say 7x plus 1, 7x plus 1. Alright, and then from there, you remove the brackets. So it's 49x squared plus 7x, which is 14x, 7x plus 1, which is going to be 49x squared plus 14x plus 1. Now, first derivative of x, we just apply that rule. Eh? So now, we are going to have 49 times 2, 49x to the power 2 minus 1 plus, now this one will be
14.
Yes, 14. Then that's 0. And then what are we going to have here? 98. X plus 14. But remember what the question says. This is 2f prime x. Now f prime 1. Whenever there is x, we are putting 1. So now 98 1 plus 14. 1 1 1 2. Simple. Done. This is one method for working out. You can even use again chain rule. Alright. Say let u is called. Some decided this is first method. You can just do like this, or you can just use chain rule. Now for chain rule, you say, remember it's f of x is called 7x plus 1 squared. You just say let u is called 7x plus 1. So what are we going to remain with? Okay, let's differentiate this one. Say du over dx is called 7. Alright? But now there you say like y is called, or f of x. Y or f of x is one thing. Is called what? U to the power 2. So dy over dx is called what? 2u. Alright? Now, remember, first derivative of x is the same as dy over, sorry, this one should be dy over du. Alright? Is dy over dx, which is equal to dy over du times du over dx. Right? So now, dy over du, 2u. Now, du over dx, 7. So what are we going to have? This time this 14u. But what is u? So it's going to be 14 our u is 7x plus 1. 40 times 7? 98x plus 40. Coming back to that one. And then this is still 5 prime x. But now we need first prime 1. So we're going to get your 1, 1, 2. So you can either use this one or the first one that we've done. Which either way, that is simple for you. But all of them are simple. Alright. But all of them, they give you the same answer. So this marks the end of 8.2. For now, let's invite Mr. Mike for question 9.
Okay, moving on to question 9. It reads, the function f of x is equal to negative 2x cubed plus ax squared plus bx plus c is sketched below. The turning points of the graphs of f are the point t, which has coordinates 2, negative 9, and the point s, which has coordinates 5, 18. Okay, and question 9.1 says, show that a is equal to 21, b is equal to negative 60, and c is equal to 43 for 7 marks. Okay, so there's going to be a lot of calculation for this question, but I'll take you through it step by step. So what we can use here, the knowledge that we can use is, once again, it's going to be calculus, derivatives. Okay, what do you know about at your turning points, right? If you find the first derivative, at those turning points, the derivative should be 0. In other words, there is no slope at that point. So at both points t and s, we find the derivative, substitute, and we should equate those two equations to 0. Then from there, we have two equations which will solve simultaneously. Okay, so let's try use that and see how far we get. Okay, so the function we're using is f of x is equal to negative 2x cubed plus ax squared plus bx plus c. First derivative will be negative 6x squared plus 2ax plus b. Okay. And at both points t and s, the derivative should equal 0. Okay, because that's the turning point. But then what do we know at point t? At point t, we know that x is equal to 2. Okay, x will equal 2. Therefore, negative 6, 2 squared, plus 2a times 2 plus b should equal 0. That's one equation. If we simplify it further, it becomes minus 6 times 4 plus 4a plus b should equal 0, which gives us 4a plus b should equal 24. Okay, since 6 times 4 is 24 this side, the negative becomes positive. Okay, that's one equation. We're going to now formulate a second equation using the same method, but then for point S. So at point S, we know that x is equal to 5. Therefore, into the same equation, it's going to be minus 6, 5 squared plus 2a times 5 plus b should equal 0. This becomes 10a plus b is equal to, then this will take over. The 5 squared is 25. Then 25 times 6 should be 150. Then it's negative 150, goes over, becomes positive 150. Okay. So now, if you check, we've got two equations. That equation and that equation with two unknowns, a and b, a and b. From this point, we can actually now use the simultaneous equation method, which you should all be familiar with by now. So from 1, let's take b is equal to 24 minus 4a. Substitute that into 2. It will become 10a plus. Then where b is, we're going to put 24 minus 4a. And that should equal 150. So from here we need to solve for a. It becomes 24 minus 4a is equal to 150. Becomes 6a plus 24 is equal to 150. Okay, 6a plus 24 should equal 150. Then ultimately 6a is equal to 126. Therefore a should be 126 divided by 6 should be 21. Okay, that's a, which we've shown. Then to show b, since it's simultaneous, we can go resubstitute into either one of the equations, 1 or 2. So we've got a is equal to 21. We know that b from here can be 24 minus 4a. So b, okay, so that's a. b is 24 minus 4a, which is 24 minus 4 times 21. If you calculate that, check that for me, it should give you your negative 60. Yeah, negative 60. Okay, and now we just need to show the last part. So to show that c is equal to 43, already from our equation, our original equation, which was f of x is equal to minus 2x cubed plus ax squared. A we now know, right? So it becomes 21x squared plus bx. And b we now know is minus 60x plus c. C is the only one we don't know now. From this equation, confirm, it's the same as saying y is equal to minus 2x cubed plus 21x squared minus 60x plus c. Okay, if we substitute one of these points, it should work out. In other words, if we let x equal 2 and y equal to negative 9, we should be able to solve for the unknown c. So what I mean by that is, we know that at the point t, x is equal to 2 and y is equal to negative 9. We can use that to solve for c. So negative 9 should equal negative 2, x is equal to 2, is negative 2 cubed plus 21 2 squared minus 60 times 2 plus what we're trying to get c. Then from there, that's a simple equation now. So to simplify this further, to be minus 9 is equal to minus 2 times 8 plus 21 times 4 minus 120 plus c, which is minus 9 is equal to minus 16 plus 84 minus 120 plus c. Therefore c should equal, we take everything over, it becomes minus 9 plus 16 minus 84 plus 120. And if you check this in your calculator for me, what does that give you? The same negative 9 plus 16 minus 84 plus 20. 43. So that confirms all three points that we're trying to get, A, B, and C. Okay, any questions?
Yeah, I wanted to ask, wasn't the sign for 9 supposed to change? Didn't you like transpose it to that side?
No. It's like I left the C this side. I took everything else. I just put the C on the other side. Yeah. Okay. Okay, so that's question 9.1. for question 9 for the rest of the question, in fact, we now know what the value of A is. So now we'll stop using the A, B, and C. We'll put the actual values in. B is negative 60, and C was 43. So that's the equation we're going to use from now on. Then, question 9.2 says, determine an equation of the tangent to the graph of f at the point x is equal to 1. Okay, we're trying to get an equation of a tangent. It's a straight line, right? The equation of a straight line is y is equal to mx plus c, or y minus y1 is equal to m brackets x minus x1. So we're going to use that to solve this equation. In your equation, y is equal to mx plus c, what two things do you need to find? M and c, right? So we're trying to find m for the tangent. And using the theory we know behind calculus, you find the first derivative. And at which point are they talking about? At point x is equal to 1. So at x is equal to 1, we find out the value of the gradient. So m, the gradient, should equal to the derivative of the equation, which becomes minus 2 times 3 x squared plus 21 times 2x minus 60. And ultimately this is minus 6x squared plus 42x minus 60. Okay, but they tell us that, so in other words, we found a function for our general gradient. But then they're specifically asking for the equation of the tangent at the point x is equal to 1. So, at x is equal to 1, m will be minus 6 times 1 squared plus 42 times 1 minus 60, which is minus 6 plus 42 minus 60. Okay, which should be ultimately, if I'm not mistaken, minus 24. Okay, so m is equal to minus 24. Cool. And then the only other thing we need to do now, like we've solved our equation, we've solved for m now, but we've got y is equal to minus 24x plus c. The only thing remaining is to find what c is. Okay. In order to go about doing that, which point are we dealing with? Once again, they tell us what to work with x is equal to 1. The only other thing that would be missing for us to get c is to get the value of y at x is equal to 1. So, when x is equal to 1, y should equal, we go back to the original equation, substitute x is equal to 1 in there to get what value y is. So we go substitute, it becomes minus 2 times 1 plus 21 times 1 minus 60 times 1 plus 43. Then ultimately you're calculating minus 2 plus 21 minus 60 plus 43. Confirm with me what you get for that. Get 2, right? Exactly. So y will equal 2. Okay, so now we can solve what c is. So our equation is y is equal to minus 24x plus c. Turning over. So we know that y is equal to minus 24x plus c. We know that when x is equal 1, y should equal 2. Therefore, when y is 2, this will equal minus 21 times x plus c. So 2 is equal to minus 21 plus c. Therefore, c should equal 21 plus 2. Or is it 24? Sorry. That's 24 there. So the 24 comes over, it becomes 24 plus 2. It should be 26. So now c is equal to 26, therefore eventually y should equal minus 24x plus 26. Okay, everyone follows. The method is pretty straightforward. You know what equation of your tangent is, y is equal to mx plus c. You need to get your m and you get your c. You get your m from your calculus, you do your derivative, calculate your gradient at that point, and then to get your c, you need to find what y is so that you solve for the unknown c by substituting for both x and y. Then from there you go down to the equation. Okay. Okay, so that's question 9.2. Quickly moving on to question 9.3. It says, determine the value, the x value at which the graph of f has a point of inflection. Okay. So the points of inflection, just like whenever you hear tangent, you do the first derivative. Whenever you see the word inflection, it's a double derivative. Okay. So what I mean by that, you first find your first derivative, which is minus 6x squared plus 42x minus 60. Then you find the second derivative, which is minus 12x plus 42. Okay. And then, just like you did with the first derivative, you solve for x, right? In this instance, we're going to solve for x at that double derivative. So, eventually we have minus 12x plus 42 should equal 0. If we take the 12th over, the 12x over, it becomes 42 should equal 12x. Therefore, x should be 42 over 12. Okay. Which is 7 over 2, yeah. Okay. And that's your x value at the point of inflection. Okay. Any questions? Okay. Moving on to the next question. Question 10. It reads,